Hi students, today we are going to learn the clamper circuit. In the second unit, second part is clampings. What is meant by clamper? Clamper which is used to add the or shifted to the desired DC level. The clamping which is used, clamping is a circuit which is used to add the signal either positive or negative to the reference level, that is known as clamping. The clampers are also called as IC restorer and AC signal level shifter. IC restorer and AC signal level shifter. Clamping is a circuit which is used to add or shifted to the above or below the reference level is known as clamping. Clamping is also called as IC restorer and AC signal level shifter. And clampers are classified into two types. They are positive clampers and negative clampers. Clampers are classified into two types. They are positive clamper and negative clamper. So let us see the positive clampers. This is the positive clamper. We are giving the input full sinusoidal signal, but only output above the reference voltage only. This is the reference voltage, but we are getting the output only at the above reference voltage. We are getting the output only above the reference voltage, only upward of the DC level. When you coming to the negative clamper, we are giving the both sides input, but we are getting the output only at the below the reference voltage, below the reference voltage. That means downward of the DC level, downward of the DC level. So let us know the operations of the positive clampers. Operation of the positive clamper. Now we are constructing the circuit diagram. For that we are taking the one capacitor, diode and input signal, that is sinusoidal signal. We are taking the one sinusoidal signal. For that, when the capacitor charging and discharging condition only, the output will be appear. First of all, we are considering the positive half cycle. During the positive half cycle, we are adding the reference voltage also here. So the reference voltage, we are the positive terminal which is connected to the anode of the terminal and the negative terminal which is connected to the ground. So during the positive half cycle, it goes to the capacitor. The capacitor is charges and diode is in reverse bias condition. It does not conduct and it can be acting as a short circuit. So the entire input which can be passed to the output. So same positive half cycle will be appear. During the positive half cycle, the capacitor is charges, diode is in reverse bias condition and does not conduct and which can be acting as a short circuit. So the entire input which can be appear to the above the reference levels. That means same input which is passed to the output. Vi is equal to Vout. And while we are considering the negative half cycle, the capacitor is fully charges and diode goes to the reverse bias condition. And which can be acting as a short circuit. and negative terminal which is connected to the anode of the diode, and positive terminal which can be added to the ground reference voltage. Negative terminal is connected to the anode of the diode and the positive terminal is connected to the ground. That means all the voltage which can be passed to the ground level. That means here during the negative half cycle capacitor is fully charges, but diode is in reverse bias condition. It does not conduct. But we are diode voltage, cathode voltage is less, but anode voltage which can be added to the negative terminal, so that the diode can be conducts. So the entire input negative half cycle which can be shifted to the above reference voltage, which can be shifted to the above reference voltage, which can be added to the above the reference voltage. That means same negative half cycle input which can be shifted to the above the reference voltage. So this is the operation of the positive clamper. First we have to consider the positive half cycle. During the positive half cycle, here we are also adding the reference voltage. Positive half cycle which can be connected to the anode and the negative which can be ground. So the capacitor is charges. Diode is in reverse bias condition. So does not conducts. It does not conducts, and entire input which can be passed to the output. During the negative half cycle, the capacitor is fully charges, but the reference voltage is changes. Diode is in reverse bias condition. Negative terminal which can be added to the cathode and positive terminal which can be added to the ground level, so that when the input signal negative cycle is applied, the capacitor is fully charges, so it starts conducting and it shifted the negative voltage to the above the reference level. Negative voltage which can be shifted to the above the reference voltage. So this is the output. And this is the input signal. But input negative which can be shifted to the above the reference voltage by adding the reference voltage. Here the cathode voltage is greater than the reference voltage. Anode voltage which can be greater than the reference voltage, so that diode conducts and it shifted to the above the reference voltage. So this is the operation of the positive clamper. Let us see the negative clamper. First of all, we are constructing the circuit diagram. For that we are taking the capacitor, diode, input signal and output. This is the input and this is the output. In negative clamper, all the output will only at the below the reference level. This is the reference voltage, reference level, but output only below the reference level. So let us see the operation. During the positive half cycle, the positive cycle which can be applied to the capacitor is charges which can be passed to the diode. Diode is in forward bias condition. Here we are adding the reference voltage. By using reference voltage only, the output can be shifted or added to the below or above the reference voltages. That's why we are adding the reference voltages. Here the reference voltage positive terminal is connected to the cathode and negative terminal is connected to the ground. That means here reference voltage is terminal positive voltage is greater than the cathode of the diode, so that same positive cycle input which can be passed to the negative level. Positive cycle of the input which can be shifted to the negative level. positive which can be shifted to the negative. So this is known as the positive half cycle. Now we are considering the negative reference voltage. During the negative cycle, we are just inverting the reference voltage. That means negative terminal connected to the cathode of the diode and positive terminal which can be added to the ground. Here both the diode and the reference voltage terminals are equal, so that during the negative half cycle diode is in forward bias condition, the capacitor is charges and it starts conducting, so that the entire input which is passed to the output, so it shifted to the negative level, same input which can be passed to the output. So entire input at the output side. This is the output waveform and this is the input waveform. In negative clamper, the output only at the below the reference voltage, In positive clamping, the output only at the above the reference voltage. This is the operations of the positive and negative clampers. This is the operations of the positive and negative clampers. So these are the important questions. So you have to concentrate on both the questions, positive clamper and negative clamp. In external exams also, they can ask two important questions, two essay questions from the clipper part and from the clampers part. So in the clamper part, there are three questions. They are positive clamper and negative clamper and clamping circuit theorem. So if you concentrate on both questions, you can gain the maximum marks. So you have to concentrate after listening the class. Once refer the notes also. We have to refer the notes also. Once again I am explain the operations of the positive and negative clampers. Let us come to the positive clamper. So this is the positive clamper input, but we are getting the output is only above the reference voltage. So first of all, you have to consider the circuit diagram. We are giving the input voltage. So during the positive half cycle, capacitor is charges, but diode is in reverse bias condition. Here reference voltage, positive terminal is connected to the anode and negative connected to the ground. So here both the diode voltages and both are equal, so that the entire input which can be passed to the output. Now we are considering the negative half cycle. During the negative half cycle, the capacitor is charges, diode is in reverse bias condition. The negative terminal which can be added to the anode of the diode. Here diode voltage is greater than the reference voltage, so that diode conducts, so that the negative voltage which can be shifted to the above the reference voltage, the negative cycle which can be shifted to the above the reference level. So this is the operation of the positive clamper. Next one, negative clamper. This is circuit diagram. Input and below the reference voltage is output. Let us consider the positive half cycle. During the positive half cycle, capacitor is charges, diode is in forward bias condition. In forward bias condition, it conducts, and both the reference voltage positive is connected to cathode, and the negative terminal is connected to the ground. So here reference voltage is greater than the diode voltage of the cathode, so that the positive signal which can be shifted to the negative level. Now we are considering the negative half cycle. While we are considering the negative half cycle, the capacitor is charges, diode is in forward bias condition, but the reference voltage polarities are inverse. That means negative terminal connected to the diode of the cathode. Here both the voltages are equal, so that entire input which can be passed to the output, same input which can be passed to the output. So this is the output waveform, this is the input signal. These are the operations of the positive and negative clampers. Positive and negative clampers. There are some applications in positive and negative clampers. There are also some different clamping circuits. These are all the different clamping circuits. These are all the clamping circuits. This is what circuit? This is we are giving the positive and negative half cycle, but only output at the negative level. That means which circuit? This is one. This is the negative clamper, and this one is the positive clamper, and this is the negative clamper, and this is the positive clamper, negative clamper, and positive clamper. These are all the different types of clamping circuits. These are all the different types of clamping circuits. Let us see the applications of the clampings. Applications of the clampers. The clampers can be used in complex transmitters and receiver circuits of the television. The clampers can also be used in the TV transmitters and TV receivers, and clampers are also used in the wave shaping circuits. That means when the wave shaping circuits are used, it uses to add the or restores the signal, and this can also be used in the sonar and radar systems, and it can also be used in the test equipment. The clampers are used in the test equipments, sonar and radar systems. Clampers can also use it to protection of the amplifiers, can also used for the protection of the amplifiers, and the clampers can also used for removing the distortions. Clampers can also used for the removing the distortions, and clampers can also used for improving the overdrive recovery time. Clampers can also used for the improving the overdrive recovery time, and clampers can also used at the double voltage levels and voltage multipliers. Double voltage levels and voltage multipliers. The clampers can also be used in storage counters, analog frequency meter, capacitance meter, divider and staircase waveform generator. Divider and waveform staircase generator. Clampers can also be used in frequency meters, analog frequency meters, capacitance meters, divider, staircase waveform generators. Staircase waveform generators. The applications of clampers are, these are used in several different applications. They are TV transmitters, TV receivers, FM stations, stabilizers, used in current restorers, wave shaping generators. This can be used in test equipment, sonar and radar systems, and this can for the protection of the amplifiers from large errant signals, and used in the removing the distortions and improving the overdrive recovery time. Clampers can also be used in voltage doublers or voltage multipliers. There are also find applications in storage counters, analog frequency meter, capacitance meter, divider, and staircase waveform generator. Staircase waveform generator. These are all the applications of the clampers. So there is another important question, that is clamping circuit theorem. So once again I am giving the overview of the second unit, that is non-linear wave shaping. In non-linear wave shaping means for the linear network we are giving the sinusoidal input but we are getting the output is non-sinusoidal. Linear network means by using the linear elements. What are the linear elements here? Resistor, capacitor and inductor. By using these components we are constructing the linear network. For that we are giving the sinusoidal input but we are getting the output is non-sinusoidal. So in this second unit we have the two parts, clampers part and clippers part. First we have discussed the clippers part. What is meant by clipper? Clipper which is used to remove the unwanted part of the signal. Clipper which is used to remove or cut the unwanted part of the signal with respect to the DC level is known as the clipper. Clipper is also called as slicer, selectors and amplitude voltage selectors, and it also called as limiter. Selectors, limiters and slicers. These are all the different names for the clippers. The clippers are classified into different types. They are classification of clippers. Classification of clippers. Clippers can be classed according to the linear devices, diode clippers and transient clippers. According to biasing, unbiased clipper and biased clippers. According to configuration, clippers are classified into series diode clipper, shunt clipper, multi-diode clippers. According to level of clipping, these clippers are important. Positive clippers, negative clippers, biased clippers and combination of clippers. These are all the classifications of the clippers. So first we have discussed the positive diode clipper. In positive diode clipper again classified into two types. They are positive series clipper and positive shunt clipper. Positive series and positive shunt. So this is the positive series clipper. In positive series clipper, first we are constructing one positive cycle. This is in reverse bias condition. So reverse bias condition so that it does not conduct. So output is the positive output is 0. During the negative half cycle, diode goes to the forward bias condition. So diode conducts same input which can be passed to the output. The output is positive half cycle. This is the positive series. In series, diode has to connect it in load to the in series. This is the positive shunt clipper. In positive shunt clipper, diode which can be added to the in shunt to the load resistor. During the positive half cycle, diode is in forward bias condition, but there is a voltage drop across the diode so that the input is reduced. In forward bias, it conducts. It has to produce the output, but the output is 0. Why? Because of there is a voltage drop across the diode, so that output is 0. During the negative half cycle, diode goes to the reverse bias condition. So in reverse bias condition, it does not conduct same input which can be passed to the output. So this is the output. This is the positive shunt clipper. Next one, negative diode clipper. In negative diode clipper, this is the circuit diagram. This is negative series clipper. Diode added in series to the load resistor. During the positive half cycle, diode is in forward bias condition. It conducts and it produces the output voltage across the load. So the output is positive. During the negative half cycle, diode goes to the reverse bias condition, does not conduct and it does not produce any output voltage. So that output is 0. So the output only at the positive half cycle. This is the negative series clipper, and next one is negative shunt clipper. During the positive cycle, it can be added to the diode which can be added in shunt to the load resistor, diode in reverse bias condition, so that the positive input is clipped off. It does not produce any output. During the negative half cycle, diode goes to the forward bias condition. diode conducts, but there is no voltage drop across the diode, so that the output will be produced. The next one is biased clippers. Here it uses the reference voltages. By using these reference voltages only, it can produce the output. So this is the circuit diagram. Positive biased clipper. Here we uses the positive during the positive half cycle, diode is in forward bias condition. So the reference voltage which can be fixed at some voltage, that voltage only appear at the output, the remaining voltage will be clipped off. During the negative half cycle, diode goes to the reverse bias condition. So the entire input which can be passed to the output. This is the positive biased clipper. Let us come to the negative biased clipper. That is, during the positive half cycle, diode is in reverse bias condition. It does not produce any voltage outputs at the output side. So entire input passes to the output. When we are considering the negative half cycle, diode goes to the forward bias condition. Diode goes to the forward bias condition. The reference voltage can be fixed at some voltage. So that voltage only appear at the output. That voltage only appear at the output. So the remaining output voltage will be fixed. Important note is, the reference voltage is fixed at some voltage. That voltage only will appear at the output. The remaining voltage will be clipped off. That is the biased. So this is the positive and negative biased clippers. Next one, combination of clippers. So here we are taking the two level clipper, two diodes, D1 and D2 diode. D1 diode is in once the D1 diode is in forward bias condition, we will get the positive voltage. When the D2 diode is in conducting position, we will get the output at the negative level. So when the D1 is on condition, D2 is off. When the D2 is on, D1 is off. So based on these operations, the output will be generated at the output. Applications of clippers are TV transmitters, TV receivers, radio transmitters, FM stations, square wave generators, wave shaping circuits. These are all the applications of the clippers. Next part is, there are disadvantages in shunt and series diode clippers. What are the disadvantages? Means, when the diode is in off condition, if you want to transmit the high frequency signal, it cannot produce. So that it is take place in the capacitance. When the capacitance takes places, there are some disadvantages. That means it produces the high capacitance. So circuit will get the damages. These are all the disadvantages from the series and shunt diode clippers. Next one is clamping. Clamping is a circuit which is used to add the signal either below or above the reference voltage. So these clampers are classified in two types. They are positive clampers and negative clampers. During the positive clamp, we are constructing the circuit diagram. During the positive half cycle, diode in reverse bias condition. Due to the reference voltage, the same input voltage which is passed to the output. During the negative half cycle, due to the reference voltage, the negative half cycle which can be shifted to the above the reference voltage. This is the operation. When coming to the negative clamping, this is the circuit diagram. During the positive half cycle, the capacitor is charges, diode in forward bias condition, and the positive signal is added. Due to the reference voltage, the entire positive input which can be passed to the negative level. During the negative half cycle, just reference voltages are reversed, so that same input which can be passed to the output. This is the input and this is the output. Let us come to the applications and different clamping circuits. There are all the different clamping circuits. Applications: TV, transmitters, receivers, can be used in current restorers, test equipments, sonar and radar systems, used protection of amplifiers, removing the distortions, override recovery time, voltage multipliers, storage counters, analog frequency meter, capacitance meter, divider and staircase waveform generator. This is the clamper and clipping part. In the next section I will explain the clamping circuit theorem, another important question. So thank you.